18-month-old Janie has severe acute malnutrition. The lack of protein has made her limbs swell and her skin peel, and she's had repeated infections. It's a deadly combination, which is the world's biggest killer of children.
Malnutrition reduces their immunity and puts them at risk of getting very severe infections, specifically pneumonias and diarrheal diseases. And when they get severe forms of malnutrition along with these infections, within a few days a significant number of them die.
Children on the ward are given highly nutritious special feeds. Made mostly from nuts and dairy, these are formulated in Europe to allow malnourished children to easily absorb all the energy, protein, vitamins and minerals that they need. And yet, Janie's prognosis remains poor.
Even when they survive hospitalization, children who suffer from malnutrition are still at higher risk of death than other children in the community. They're at risk of getting more infections or even a recurrence of severe acute malnutrition. Some of these deaths are not even recognized because children die within the community and they are not counted in health facilities.
Many doctors and researchers working with children with severe acute malnutrition are worried that something in the treatment is missing.
For the last 30 odd years, we've had very good feeds that rescue people from malnutrition in the terms of body composition. But this mortality rate of 25–30% in this very sick population has maintained. So this is unlikely to have something to do with actual energy and protein. This is about something different.
The peeling skin caused by malnutrition is only what we can see on the outside. Inside, Janie's gut wall is also severely compromised, making her vulnerable to infection.
If you look at very malnourished children in Africa, their guts have little holes in them, and those holes can let in bugs and set up sepsis.
For the last 10 years, researchers working on the MIMBLE project have been trying to find local foods which can help repair the gut lining of children like Janie. They believe this means restoring the microbiota, the trillions of bacteria and other microbes that make up the human gut microbiome. These bugs feed off the fibre we eat.
The bugs use the dietary fibre for energy and growth, and the kind of side product, their waste product if you want, are a series of chemicals called short-chain fatty acids, and they improve the barrier of the gut.
We inoculate with human fecal samples, so that establishes the human gut microbiota in this small vessel.
At Reading University, they've built a replica digestive system in the lab, where they've been testing the different foods from Africa.
When you test something from Africa, you can directly put it in the top container. So that will flow through the colon, our human colon, and we can compare then how gut microbiota changes, and we also look at short-chain fatty acids, which is the byproduct of bacteria in the gut.
The current high energy and protein feeds given to malnourished children contain no dietary fibre at all, and in the lab were shown to do little to stimulate the microbiota. By contrast, local beans were very good.
The locally produced beans or legumes actually seem to ferment better than a more industrially produced dietary fibre.
Other studies in this lab have shown similar benefits from local vegetables in West Africa.
This particular food was able to stimulate the production of short-chain fatty acid, which has been linked to reducing the impact of malnutrition in children and increasing recovery rates in children.
After the lab results, researchers have done 2 pilot studies in Uganda. These showed that the new locally made feeds are not harmful for very sick malnourished children. and they boosted levels of short-chain fatty acids, which protect the gut lining. This appears to translate into a clinical benefit.
We think that we see that those children that were given the feed on admission and continue on the feed all the way through get an advantage. These children seem to be less sick, and there seems to be a pointer towards less children dying in that arm.
To be sure, this needs a much bigger study. Based on these preliminary results, the researchers have partnered with a Ugandan company which is already producing ready-to-use therapeutic foods. They've developed a new feed for the MIMBLE project, made entirely from produce you'd find in a local market.
We have worked on a variety of inputs, beans, we've looked at different varieties, sweet potatoes, we've looked at different varieties, as well as soya. We source these products through smallholder farmers, and we work with them to make sure that the quality meets local and international standards.
The feed contains important innovations. Protein comes mainly from soya, which is cheaper, more environmentally friendly, and less susceptible to bacterial contamination than cow's milk. It has no dairy products, as intolerance to lactose, the main sugar found in milk, is common in malnourished children. Carbohydrates come mainly from dried flour made from different potatoes. The MIMBLE feed will be from 15 to 25% cheaper. But the question, still to answer, is how much clinical benefit it might give to children compared to current feeds. That needs a randomised controlled clinical trial.
The next step is to do a very large study that demonstrates that this feed does what it says on the tin. It protects the gut, and by protecting the gut, it actually reduces the morbidity and the mortality in those children. It's very radical. By adding a component that is used by the bugs to actually enhance the gut integrity is a total different way of thinking about feeding.
Most of the products or the foods that are used to treat malnutrition are often from Europe or from developed countries. And so we need to look at more sustainable ways of treating malnutrition.
We really see a huge change in terms of how we deploy for both emergency and non-emergency situations of severe malnutrition. The process and production is much simpler. You don't have a huge waiting period.
I believe that the gut microbiota has a very big potential, so more research is needed in this direction.
It's an area that needs to have high quality research. The evidence base at the present time needs to be strengthened to understand just how important the gut microbiota is and feeding the gut microbiota is.